So how do we apply visualization for classification problems? So in classification problems, of course, recall we want to classify the label. We have different categories of the label, and we have features, of course, to do that. What we want to see is if we have features that have values that are distinct or that are separate or separable for different label categories. So that's kind of a different thing we're looking for than when we look at the relationships for regression plots. So let me show you 3 different examples of how we can do that. So on my screen here, I have some code, and the first thing we're going to do is create some box plots. So we have these numeric features: loan duration in month, loan amount, loan payment percent of income, age in years, number of loans, and dependents. And our label, in this case, is bad credit. So we want to see whether these customers are a good credit risk or a bad credit risk, okay? And so we're just going to use the Seaborn box plot method to plot whatever these numeric values are grouped by bad credit or good credit. In this case, we only have 2 categories that we're trying to classify into. So let me just run that. And we see, for example, that for loan duration in months, it seems like for bad credit is 1, good credit is 0, right? So it looks like longer-term loans tend to be more indicative of a customer having bad credit. And you can see there's the bulk of this distribution is below the median of this distribution. So that's good. I mean, that looks like we have a feature there that's going to help us separate those 2 label categories of good credit and bad credit. Let's look at the loan amount. Well, it's not quite so distinctive. You see that there's more overlap of the interquartile ranges and quite a few outliers. Maybe it helps, maybe not. We get to a feature like payment percent income. It's actually hard to read the box plot, but you see there's a limit probably imposed by the bank of 4%. And that also turns out to be the median for bad credit customers, whereas the median for good credit customers is 3%. So again, that's probably a significant feature. We get age in years. Okay, so now we really have almost complete overlap of the interquartile ranges and even the whiskers. So it's very unlikely that age of the customer really has much to do with their credit rating. And similar number of loans is a little tricky here because most good credit customers don't have any loans. That's the median value, whereas to get bad credit, a bad credit customer has to have at least 1 loan, right? So, and things like number of dependents is useless. And we can do the same thing with violin plots and maybe get a little bit different view of those separations. So let's go ahead and do that. And remember, we said loan duration a month looked promising, and you can see it's not a night and day difference between those, as we already knew, but there's definitely a longer tail on bad credit customers. So longer loans do seem to trend toward bad credit. Loan amount, again, has a longer tail. But the modes, interesting enough, the modes are exactly the same for good and bad credit customers. So maybe that's not such a great feature. And then you get things like percent income, where the median is considerably different. You see there's a longer tail down here, but it's not that different. And remember, we said age in years was pretty irrelevant, and it's definitely confirmed here. These shapes are virtually identical. But you start to see that none of these differences are that radical when you really look at the kernel density estimate that is projected in the violin plot. And again, like number of loans, completely in number of dependents. Most people don't have one dependent. So, okay, so what do we do about categorical features? So we've just talked about separating by categorical features, but most of our features in this data set, checking account status, credit history, purpose, savings account balance, time employed, et cetera, those are all given as categorical features. So we have to do some bar charts. And it's a little bit complicated code here, but basically what I'm doing is I'm creating a bar chart on one subplot and another bar chart on another subplot for good and bad credit. So that's why a lot of this code looks a bit redundant here. So let me just run that and you'll see what happens. And so let's look at the first one. So this is checking account status for bad credit and good credit. And you see one of the things that stands out, so the labels are exactly in the same order here. That's something I've done, because otherwise it's really hard to compare these things if you don't have the labels. So no checking account seems to really stand out for bad credit customers, whereas our good credit customers tend to have at least some balance, and sometimes they have less than zero balance, which is kind of interesting. But then you get to a feature like credit history. Well, there's one difference. They have a critical account. Okay, a critical account is an overdrawn or overdue account. And so, yeah, bad credit customers definitely are more likely to have that. But you see, in terms of the overall frequencies, that may not be that indicative, because most customers are paying their current loans regardless of whether they're a good or bad customer. So we're not sure how good a feature that is, et cetera. And we can continue to go through that. And we're just looking for differences, like car loans are less likely to read to bad credit, whereas radio and television seem to stand out as maybe red flags for bad credit customers, et cetera. I'm not going to go through all these, but I just wanted to give you the flavor of how you look for good versus bad credit customers, or separate any label category. So we've looked at using box plots and violin plots to see if a numeric feature separates our label cases. And we've looked at using side-by-side bar charts to see which categorical features help separate our label cases.